I'm going to talk about the SpiNNaker NRP Synchronization project. Basically, the idea of this project is with the HBP Neurorobotics Platform, we want to synchronize SpiNNaker. So the Neurorobotics Platform is basically a way of simulating robots, and with having a brain simulation on a brain simulation platform and sort of linking these together with transfer functions. The general way this works is a sort of synchronous control. So in the past, it's been that you sort of have a brain simulation run for a bit, then you do some transfer function, then you have the robot run for a bit and transfer functions, basically. So each bit happens sort of independently. And this keeps things in sync, which is great. Now, we have already had some interfacing of SpiNNaker with the NRP. So basically, this links together SpiNNaker instead of Nest, so you can do your simulation on SpiNNaker instead. And this has already been successfully done. The problem with this is that it's sort of an asynchronous control. So what happens is all these bits are sort of happening independently of each other, and so things can get out of sync a bit. To give you sort of an idea of how this can go wrong, if you imagine this is the simulation here, and you've got the simulation times on left and right, basically we might, for example, sample membrane voltage to use that to control the robot. So at one time we sample the membrane voltage and we store that in a little bit for the robot to be able to read at some point. Now, if the SpiNNaker simulation is proceeding faster than the robotic simulation, you might take all these membrane readings, which then get stored in a space, and the robot hasn't progressed at all. So now the robot reads the value, but it's only reading the last value that you've read, which means that you've not been able to get the full advantage of all those different movements in membrane voltage throughout the simulation. We do have some ideas on how to make this work, and we've had some work recently on SpiNNaker to do this. And the question is now to integrate that. So on SpiNNaker, basically we can start the simulation, say run it until it's stopped. But what we can now add is to say, and do that in n step increments, so you can have a fixed number of steps before it pauses in the middle. The idea then is that starts it running, and then at some point it pauses the simulation when those number of steps has happened. So now you can say continue the simulation, and it will then continue until the next increment, and so on and so forth. So you can keep sending these continue signals for each number of steps. So the hope in this project then is to add the NRP into this loop. So currently we can do this from a SpiNNaker script, and I have an example of that working, but I'd like basically to integrate this with the NRP. The idea of this project then is, first of all, to get that integration working, which is a reasonable task in itself. It'll depend on, I don't know enough about the NRP necessarily to integrate this in, so it'll be useful if someone from the NRP comes along and helps out. Once that's done, also anybody who was interested in using the NRP with SpiNNaker could come along and give this a go if we manage to get things working. Basically, that's the idea. So yeah, that's it really. Any questions?